Hi there, today we're going to be talking about functions. So it says here in our definition box that a function is a relation in which each member of the domain, which is our input value, is paired with exactly one member of the range, that is our output value. You can organize the input, the rule, and the output of a function using a function table, which we can see right here. So our input, which is our domain, is often essentially our x value when we're talking about how we're going to graph these on a graph, right? The rule becomes, in a sense, what you think of what we've been talking about, kind of the equation we've been dealing with, 2x plus 4, whatever it might be. The output becomes our range, which is often the y value, okay? So, in many cases, this is our independent variable, and this one is our dependent variable, because what happens here depends upon what we input over here. So those are some terms you probably have heard throughout the last several years and how they all kind of fit together in a nice chart. So you input an x value into an equation and you get out of it the y value, right? So if y equals x plus 1, if you input a 1 into that equation, 1 plus 1 is 2, then y equals 2. So you're inputting a 1, going through the rule, and you're getting out the y value there. And that's what we're talking about when we're talking about functions, okay? So I oftentimes think about this f of x is where kids get a little confused as they go, oh, is that another x there? It's working much like you had before, that y equals 2x plus 4. But now that's a function, it means that we're going to be putting several values of x in place here in order to determine several values of y. Okay, so it says here to choose 4 values for x to make a function table for f of x equals 2x plus 4. Because you can choose 4 values on your own, you really can select any values you want. It's often good to select a -1, a 0, and 1 so that when you end up graphing, you have some value that's on this side of the y-axis, one that's on the y-axis itself, and one that's on this side to really kind of help your graph and know where it's going to go. The other value could be a 2 or -2, whatever it's going to be, but these are generally really good values to plot if you're trying to make any kind of graph. To start with those 3 right there, it'll give you a good idea of the direction of your graph. Okay, so in this case here, you can see they took the -1 and they put it into the rule. So we can say instead of an x here, they replaced the x with a -1. So 2 times -1 is -2 plus a +4 and comes out with a +2. All right. So again, if I'm graphing this, thinking about a graph here. Here's 1, 0, 1, and 2. We have here 1, 2, 3, 4, 5, 6, 7, 8. I'm going to go to 8 because I see that there. So at -1, we're at +2. When you put a 0 in that place, 2 times 0 is 0 plus 4 is 4. 1, 2, 3, 4. That becomes our y-intercept, which we would know looking just at this. That's our y-intercept is at 4. When you put a 1 in, then you get 2 times 1 is 2 plus 4 is 6. And end up here like so. And so with just those 3 values, you could make a graph of what that would look like. Again, I could plot the 2 out here, becomes an 8, and it continues on up here, right? So that's what that would look like there. Now, when it wants you to state the domain means what are all the input values that you're using. In this case here, the domain in this case, what we chose was -1, 0, 1, and 2. The range becomes all the y values that are the result of running through the rule. So 2, 4, 6, and 8. Those are all the range. So this becomes our domain, and this becomes our range. In a sense, this is our x values. These are our y values. Okay? So that's the basics of how the function works, how it works with a chart or a table, how you can organize it there, and then how you can graph it as well. You're not being asked to graph anything today, you're just being asked to determine what the value is going to be by placing a number into the rule and what comes out the other side, and then making your own table. Let's look at a couple more examples here before you jump off on your own. So for the first one, it says f of 1, which means we're going to say that if x equals 1, what is the function, or what is y going to equal? So if we plug a 1 in here, we get 1 plus 3 equals 4. So we would say that f of 1 is equal to 4. So essentially we're just plugging it in and seeing what we come up with. F of 6 means, all right, let's plug this into here. We get 2 times 6, which equals 12, which is saying that if the x value is 6, then the y value is equal to 12. Going through the rule, we end up over there. Over here, if x equals 4, if f of x is 4, then we plug it in. 5 times 4 minus 4. 5 times 4 is 20, minus 4 is 16. So y would equal 16 when x equals 4. Okay? Hope you're getting the idea there. Just be careful with ones when they're like negative, like this, for example. If I have a negative 5, we want to plug them in properly. We have negative 2 times a negative 5 plus 8. Negative times a negative is a positive. 2 times 5 is 10, plus 8 equals 18. So when x equals negative 5, y equals 18. And again, that really is giving you 2 points on a graph, if you were to graph that out there, for where that would be. Now, in the next section, it's the same idea, but now it says to choose 4 values. And again, I would suggest always doing negative 1, 0, 1, and then do a 2. Just keep it simple for yourself. Again, no reason to work with some crazy numbers. Don't pick 17 and 23. That's just going to be crazy. So now we're going to plug that in there. So if I put a negative 1 in here, that means I have negative 1 minus 10. Well, negative 1 minus 10, when I do subtraction, remember we add the opposite. So now the signs are the same, so I find the sum and keep the sign the same. The next one, I put a 0 there, minus 10. Again, add the opposite, so I end up with negative 10. If it's a positive 1, it's 1 minus 10. So again, add the opposite. Negative 10 and a positive 1, I find the difference because the signs are different. And I keep the greater absolute value sign. And the last one, 2 plus a negative 10 becomes the same thing, negative 8. And again, you can see that pattern. It's going to be a straight line. Why? Because when I'm going up by 1 here, I'm going down by 1 there. And that pattern continues every time. So we know it's making a straight line, and I'm good there. For the next one, same idea, negative 1, so we have 2 times a negative 1 plus 6. 2 times negative 1 is negative 2, plus 6 is a positive 4. The next one, we do 2 times 0 plus 6. That becomes 0, so 6 is what I have left. 2 times 1 plus 6 is 2 times 1, which is 8. And then over here, we have 2 times 2 plus 6, which is 4 plus 6, which is 10. So the same idea there. I'm using the rule, following along there. Sorry, I forgot to say, it does want you to state the domain and the range. So in this case here, our domain is going to be negative 1, 0, 1, and 2. And you write it with these little like curvy brackets like that. And our range is going to be, in this one here, negative 11, negative 10, negative 9, negative 8. Okay, domain here is going to be equal to negative 1, 0, 1, and 2. And our range is equal to 4, 6, 8, and 10. Okay? So that's the idea, and that's all we're doing today, is you're basically just taking a value for x, plugging it into the rule, and seeing what the y value is going to be, or what the function value is going to be, and stating the domain and the range. Okay? So do that for the next on the next page, and we'll come back and check it together in just a moment. Good luck. All right, here we go, looking at the odds for functions. So we're going to take, first of all, the 2. So when x equals 2, what does the function come out to be, or the y value? So we plug a 2 into there. We have 2 plus 4, and that's going to equal 6 for the first one. For number 3, when x equals 3, what happens here? Well, we get 2 times 3 plus 2. Well, 2 times 3 is 6, plus 2 is 8. So when x equals 3, y equals 8. Next we have negative 7. So when x equals negative 7, what does y equal? Well, we're 3 times negative 7 plus 6. So 3 times negative 7 is negative 21 plus 6. becomes a negative 15. The signs are different, so I find the difference. 21 minus 6 is 15, and I keep the greater absolute value sign, negative 15. Next one, when x is negative 5, well, we have 4 times negative 5 plus 2. I'm going to multiply. The signs are different, so I end up with a negative 20 plus 2, and then I end up that becomes a negative 18 right there. And number 9, we have negative 5 times a negative 4 minus 3. So negative times a negative is a positive, and 20 minus 3 is 17. So when x is negative 4, y is positive 17. All right, just plugging them in and seeing how that works there. For the next part here, we're going to go ahead and just put our values in, negative 1, 0, 1, and 2, and then we plug it in and see. So negative 1 minus 13, we're going to add the opposite. The signs are the same, so I find the sum and keep the sign the same. Next one, 0 minus 13 just becomes a minus 13. 1 minus 13, I'm going to change it to add the opposite, so end up with a negative 12. And then 2 plus a negative 13 becomes a minus 11. And again, you should be able to see a pattern as you go through those there. Our domain in this case is going to be negative 1, 0, 1, and 2. And our range of values, our range of outputs that we got with those domains is negative 14, negative 13, negative 12, and negative 11. All right, number 13. All right, we're going to do negative 1, 0, 1, and 2. So we do 2 times negative 1 minus 3. 2 times negative 1 is minus 2. Minus 2 plus a minus 3 is a minus 5. Then we'll do 2 times 0 minus 3. So that becomes a minus 3 there. 2 times 1 minus 3. We end up with 2 plus a minus 3 is a negative 1. And then 2 times 2 minus 3 is 4 minus 3, which is simply 1. So we can see we're increasing by plus 2 every time right there. Again, there should always be a pattern if you're doing it right. Our domain is going to be negative 1, 0, 1, and 2. And our range is going to be negative 5, negative 3, negative 1, and positive 1. Number 15. Again, negative 1, 0, 1, and 2. And like I said, you could have chosen different numbers. So what I said I was going to do in our lesson was use those same numbers here. Up to you what you wanted to do. So we have 7 times 3 times negative 1. Okay, so, all right, so this becomes a little question. If I do 3 times negative 1, then I have negative 3. So I end up with 7 minus a minus 3, which is like adding, so you end up with 10. Okay, if I do 0, then I have 7 minus 3 times 0, or 7. If I do 1, then I do 7 minus 3, which is 4. And if I do 2, I do 7 minus 3 times 2, which is going to be simply 1. And we can see here we're subtracting 3, subtracting 3, subtracting 3 all the way down. Our domain, again, is negative 1, 0, 1, and 2. And our range, again, is 10, 7, 4, and 1. All right, and our last one, negative 1, 0, 1, and 2. So I have 1 minus 4 times negative 1. That becomes a negative 4, right? This part here is 4 times negative 1 is negative 4. So minus a minus 4 is plus. So we have 1 plus 4 is 5. When we do 0, we have 1 times 4 times 0, which is 0. So we end up with 1. When we do positive 1, we have 4 times 1, which is 4. 1 minus 4 is a minus 3. And when we do 2, we have 4 times 2 is 8. 1 minus 8 is going to be minus 7. So we can see we're decreasing by 4 each time. That's our pattern, so we're in good shape there. It happens the same all the way down, so we knew we did our math right. And our domain is going to be negative 1, 0, 1, and 2. And our range is going to be 5, 1, negative 3, and negative 7. All right, that's a little bit about functions today. We'll look at some more things next. Have a great day.